Welcome back to Digital Logic videos. This particular video is a continuation of the Verilog discussion. Earlier, we've had how to install the development environment, which we use ActiveHDL, as well as talking about the basic structure of the program, how does it fit into the broader process of design. And then we've talked about syntax, types, and assignments. Now we're getting to the last but not least portion of features of the Verilog language, and that's flow control. And it's once again, it's very, very similar to what you know in C, but it's worth just going through it. There are some minor details of syntax that we need to cover. So the same way that C allows you to do if then else, this would allow Verilog also allows you to do the if then else, much like C. If the condition is true, and you can use any of those relational operators that we have: equal, not equal, less than, greater than, less than or equal, greater than or equal, that we talked about earlier. You can use any of those conditions, and if it evaluates to true, then the true statement or T statement will be executed. You can have one or more statements in here. And if it evaluates to false, then the false statement gets executed. And the really big difference between this and C, if that you want to call it big, is that it uses begin and end instead of using open bracket, close bracket like we do in C. So by now, you're used to that being the way it works. Here's an example. It says test is hopefully a 1-bit wire or register. We are comparing it to a 1-bit binary value of 1. If it's equal to 1, then we're going to say set the count equal to 2, and we're going to set the right data value to 16-bit hex, 16 hex digits. I don't know why this is that big of a. So 16 character, which is a pretty, so it's got to be lots of zeros on it. And then else, if it's not true, then we're going to subtract 1 from the count and set the right data to 0, and that's all that does. Case, if you got lots of if then else's, if you got to compare an expression or result of an expression to a bunch of different values, yes, you can write if then else, if then else, if then else to do that. Case is a little easier. Switch or case, pretty much the same. In this case, you say what the expression is that evaluates, and if it's equal to expression 1, you do whatever is here. If it evaluates to be equal to expression 2, you do all the statements under statement 2. And if it's 3, you do the third one. And default, if none of them matches, then the default is executed and you're end of case. Each one of these, so that's one process, one way to do it. Here's an example of it. This is there is one statement here. You could have more than that if you wanted to. Basically, the next case terminate the first case, and so you don't have to have necessarily break after each one. While loop, same as C, once again, while whatever the relational evaluates into. If it's true, you execute. If it's false, you don't execute the statements, and you follow it after this. Here's an example. Count is 0, and it's going to count from 0 to 12 by 3, pretty much. For loop is always useful. For loop is a special case of a loop where you have the initial condition, the condition you're going to test, and the end expression all built right into one statement, so you don't have to write separate items. And then you do a begin, end, and body of the loop. So as long as you're between initial and end expression, and you meet the condition, then you execute, otherwise you don't. In this case, you're counting from 0, and then you check into C if count is less than 31. If it is, you execute, then count is incremented by 1, and repeat. Just to remember, this happens in the beginning once, and this happens at the end of the loop every time. And that's pretty much it. We're not going to there's not going to be a video specifically for modularization. This, as long as we are here, might as well talk about it. It's a way for us to be able to break our code to smaller function C or modules here, where you would basically build a bunch of modules, and then your main module, the top level, this we call the top level module. Once it gets executed, it brings all the sub modules to do the work instead of having all the code fit into a single module. Our focus for this video was very much on the talking about these what we call flow control statement or constructs we have, if then else. The first one we talked about case, and then we got into the while loop and the for loop, and that was pretty much it. And that brings us to the end of this video. Thanks for watching. See you next time.